Let's do some honors physics together, my students. But today, instead of kind of like learning a lot of new information, we're going to apply what we know. So, what you're about to see is two different examples. One dealing with velocity and acceleration, and one dealing with displacement and velocity. So writing down the example, a cat going forward at 16 meters per second slows at a rate of -4 meters per second squared. How long for it to go or end at rest? I believe how long for it to stop. Now, how I want you to approaching this is underlining things and figure out what it means. You could see, however, by looking at the units, I can figure out the starting velocity. I don't know what slows at a rate at, but I know meters per second squared is acceleration. So I'm going to write down underneath it the list of everything I have based on just analyzing the situation from the half sheet of paper. The starting velocity, the acceleration, the time, and the phrase stop means that it's an end or final velocity of 0. But let's turn it into other words. See how I write this. Starting at 16, ending at 0 is like going from 16 to 0, and acceleration -4 means you lose 4 every second. How long does it take to go from 16 to 0 by losing 4? 4 seconds. Now, let's say that the cat keeps going backward with an acceleration of -4. I'm now going to have you figure out how to get the velocity, how to get the time if it ends up at -12. You can see I'm still underlining it. I'm figuring out what the starting velocity is, what the final velocity is. I'm trying to figure out what we know. I'm going to make a list. The starting velocity is 16 because we're looking at from the start. That was the original situation. The situation is still -4. We're trying to find how long it's a time. And the final velocity is no longer 0. It's actually -12. So, of course, I'm going to rewrite this. It's like asking, how long to go from 16 to -12 if you change by 4 every second? Let me show you how I did this. First of all, I know way from 16 to 0 is 4 seconds. And now I'm going to go from 0 to -12. Again, I changed by -4, so it's going to be an extra 3 seconds, total of 7. Now for a segment kind. You can see what I'm writing here. I can't stress enough how important it is to underline and figure out what you're given from the units and the context of the words. If you just start doing the math without doing this, you are a fool. You can see right here I wrote down some words. You go forward at 12 kilometers per hour for 15 minutes. You still go forward 3 or 4 kilometers per hour for 10 minutes. What's your overall velocity for the combined amount in meters per second? I'm leaving forward. Kilometers per hour is velocity. Minutes is time. Forward is positive. Velocity, time. Overall velocity in meters per second means you have to convert. Velocity is displacement over time. I want to figure out the overall displacement, overall time. Overall time is easy. 15 and 10 is 25 minutes. I want to get that in seconds for meters per second. And I get to figure out the overall displacement. So I'm going to use that velocity as displacement over time in both segments separately. So velocity for the first segment is 12 kilometers per hour equals displacement, which I don't know. So I'm going to put down d, and the time is 15 minutes. Now to solve for d, I multiply both sides to 15 minutes. But you see, I can't actually convert kilometers per hour times 15 minutes. They're different units. So watch what I'm going to do here. I'm going to turn the hours on the bottom to minutes and then multiply by 15 minutes. You're going to see the hours cancel, the minutes cancel, unless they're just kilometers. And if you do the math, you get 3 kilometers. Cool, that's the displacement for the first segment. I need it again for the second segment, using the numbers from the second segment, 24 and 10. Look at the same thing I'm doing. I'm going to end up multiplying to get d, but there's different units. Therefore, I have to do a little math, convert the hours to minutes so they cancel out, and I'm left with 4 kilometers. So combined, the total is 7 kilometers. But I wanted in meters, not kilometers, so it's 7,000 meters. Convert the minutes to seconds, and since velocity is spaced over time, I get 4.6 meters per second. Let's do some physics.